All right. Good evening. My name is Will Carnan. These are my partners, Dan Medeiros, Kyle Riley. And our capstone project is a germicidal ultraviolet light enclosure for the disinfection of medical equipment to prevent hospital-acquired infections. This project was brought to us by Jordan Anderson at the Providence VA Hospital. So I'm going to bring your attention to these two graphs down here. And these are just showing us the 5 most common hospital-acquired infections in the U.S. Basically, the U.S. spends over $9.8 billion a year on these 5 specific hospital-acquired infections. And more importantly, these 5 infections are responsible for more hospital deaths than AIDS, breast cancer, and car accidents combined. So these 5 infections have a direct correlation to unsanitary medical equipment. So we chose to focus specifically on oxygen tanks. And the current method of cleaning these oxygen tanks is basically to just wipe them down with a disinfection wipe. And it's not really someone's specific job to do that. So you might have that guy that comes in that wipes it clean and uses a whole box of wipes, or at the same time you'd have someone that comes in and goes clean, puts them in the clean room. So we definitely want to eliminate that human error, and that's what the UV disinfection is going to do for us. More or less, we're going to shove it in the cabinet, we're going to turn the light on, and it's going to be clean. That's it. There's really no human error in this. We're going to have UV detection stickers that go on before they go in. So basically, the sticker changes color after it's exposed to UV light. So that'll tell us that yes, this oxygen tank is definitely clean. It's been through our device, and you can shove it into the clean room.
So the technology that Will is referring to is ultraviolet germicidal radiation. This is a disinfection method that uses UVC light to inactivate microorganisms. It does so by destroying nucleic acids in there, and then deactivates its DNA. By doing so, this will allow the device to kill the microorganism and inactivate it to disrupt its vital cell function. The chart right here, this dotted line is the germicidal effectiveness. This span right here is the UVC wavelengths, and the most effective wavelength we were shooting for is 266 nanometers, which is the peak of UVC, which is why we chose these bulbs. The lamps that we chose use the UVC at 266. We currently have 3 bulbs in there, and we are practicing the amount of exposure that they get. Because we're using radiation, we've taken some safety precautions. In order for this circuit to be on, the LED light has to be shown to have the circuit complete. We are also working on adding a magnetic actuated switch in there so the device cannot be open and be on at the same time. By doing so, we will not be able to allow radiation to the operator, and we will also be able to use this enclosure to direct the light towards the medical device. This technology does exist. It is used in the medical field today. However, it is not used in enclosure form like we have done so here.
Alrighty. So like Dan said, this is our prototype unit. We're looking to establish an effective time that the objects placed inside are exposed to the UV light to see how much bacteria is killed. We're looking to use clean trace swabs and UV light sensitive stickers to measure those changes. In terms of a full-scale endgame prototype, it will be approximately the size of like a common household dishwasher. We're looking to have it accommodate multiple E-size cylinders that were the most common size used in the VA hospital when we went to visit. It will be set on 4 caster wheels, which will allow it to be easily maneuvered around the hospital. It can enter multiple clean rooms, and then an assistant can load it in, press it on, and it goes from there. It will have a large front-facing sliding door, and we're looking to load 1 to 4 tanks in at a time, and that will definitely boost productivity numbers. Any questions?
The bacterial die only when they are directly exposed to the
Correct.
UV, right? You concerned about the dead space, especially in the
Yeah, so
oxygen tank,
that's why we're looking at different numbers of lights right now. So we have one coming down from the top, from the lid, and then we're looking to see how many lights on all the walls.
How about
are necessary.
reflection light? Would they also, if you coat the inside it's like a mirror,
Yep, we're looking at code.
that works, right? That also works.
The enclosure itself, the steel, allows it to reflect a little bit, so we want to start off with this as a baseline and then increase the amount of lamps in there as well as the reflectiveness in the inside and see if that also
They
increases the
sell the reflective paint.
Yes.
You
yeah,
may
we
want
can
to
do
check that. If
Yeah,
it
for
works
now,
for
we're
you.
just gonna put aluminum foil in there, and then we're just cautious of the temperature of the box,
Right.
which is a confined space. So we're looking to, take it slow at first.
You
with the
you
amount of
use the
lights.
word radiation. That makes me nervous. This is a
Yeah, that's why
harmful-
there's a nice fancy latch on the front of this, and.
So it's harmful to people.
Yes, there is a danger of skin cancer, rapid sunburn from exposure from this type of technology, which
It's
is why
basically a fancy tanning machine, right?
Yeah, exactly. If you'd like to be our first.
No, thank you.
You like danger because you have the UV, but you're also putting oxygen in an enclosed container. I don't know if there's some way of making that permeable, so if there was a leak in the tank and you got, high temperature voltages and oxygen.
Absolutely, yeah. We have spoken with the VA hospital of what that oxygen company is contractually obligated to meet safety precautions. For example, they are obligated to have the insides of the tank disinfected, but obviously through transportation and whatnot, they become disinfected in the hospital. But the oxygen tank companies are contractually obligated to meet certain requirements.
I think an explosion will certainly kill all the bacteria, including the operator. Thank you very much. Okay, excellent work, and thank you for